Hello, welcome to Converging Dialogues. This is Xavier Bonilla. On this episode, I'm talking with the wonderful Joseph Graves Jr. Joseph is a professor of biological sciences at the Department of Nanoengineering, which is part of the Joint School of Nanoscience and Nanoengineering at North Carolina A&T State University. He has a BA in biology from Oberlin College and a PhD from Wayne State University. Much of his research areas are in evolutionary theory of aging, which gave him prominence early on, and also he's written on the biological concepts of race. He's published a handful of books, including the most recent, A Voice in the Wilderness. A pioneering biologist explains how evolution can help us solve our biggest problems. And that's what we talk about in this conversation. We start out by talking on why he wrote the book as kind of a half memoir, half popular science book, and how he chose to go about doing that. We spend much of the time talking about his life and many of the things that he went through and how he came to do biology and studying all the wonderful things he studied and some of the things that kind of put him on the map, so to speak, within the biological sciences world. We talk about some of his early beginnings and how they shaped who he became. We talk about how he became interested in biological sciences in undergrad. We talked about some of his work, early work on aging. We talk about his work on race and IQ. And throughout the conversation, it does go from kind of narrative account of, a kind of autobiographical kind of account of where his life has taken him, which is absolutely fascinating. And he talks about all these kind of pivot points. And then through that part of the conversation, we also talk about some of the science that's involved as well, which was really, really wonderful. And much like the most recent book he's put out, it kind of reads that way too. It's a little bit of his life experience and a little bit of the science, which is really, really wonderful. It was really a big honor to talk with him. He's done fantastic work, and he continues to do fantastic work at all levels. As always, you can subscribe to my free Substack, convergentdialogues.substack.com, and hear this episode and all other episodes. And now I bring you Joseph Graves Jr. I'm here with Joseph Graves. Joseph, thank you so much for coming on the podcast. I've been looking forward to talking to you.
Honored to be here with you today, Xavier.
Yeah, of course. You have written a fantastic book, which I am very excited to talk about. It's a personal book. It's obviously a great science book. You're great at communicating science, so it's so many good things in here. But before we get to that, just tell folks your potted biography, who you are, we'll talk about your background a little bit, but just kind of your elevator speech, what you do, where you're at, what you study, and what your emphasis is on.
So I am Dr. Joseph L. Graves Jr. I am professor of biological sciences at North Carolina A&T State University. My research involves understanding the genomics of adaptation using experimental evolution tools. I've worked in fruit flies. Now my work tends towards bacteria. I am currently the associate director of the new National Science Foundation Generation 4 Engineering Research Center of Excellence entitled Precision Microbiome Engineering, or PREMIER. In this work, we're looking at, how to better understand how microbial communities work in built spaces so that we can prevent people from getting sick.
That's great. Yeah, I mean, that's super. All of it's important, but that last bit there is definitely super important. Well, your book is kind of sold. So the book is called A Voice in the Wilderness. A pioneering biologist explains how evolution can help solve our biggest problems. And it's kind of billed as, half popular science, half memoir. And that's certainly how the book kind of reads. I guess when you went to write this book, I know you've written a few other books, but was that very intentional from the beginning, or did you just kind of fall into it of like, my own story kind of fits well here to explain some things, or did you want to write a memoir and then you started putting the science in? Just kind of tell us how you decided to write the book this way.
Well, the book's format, and it was really a conversation between myself and the acquisitions editor at Basic, TJ Kelleher. He was very interested in my personal story in terms of how I became the first African American to earn a PhD and become a prominent evolutionary biologist. But he also wanted to know how I thought about contemporary problems from the lens of an evolutionary biologist. So it sort of came together in that way. I wanted to tell what I thought were important stories, particularly about my formation along the path of becoming a research scientist. But also, I really wanted to get across to people that evolution is something that's happening now, and that it's exceedingly crucial to understand how it works to be able to deal with the existential problems that we are currently facing.
Yeah, I think that's important because most people see evolution as something of the past, or there's many things in our people say evolutionary history, but evolution is still ongoing and it is still occurring. And so I think that's a really, really nice angle there, which is you put it throughout the book in different places, which is super nice. So
I want to point out that people have had an opportunity to actually see evolution happening in real time in the last couple of years. The SARS-CoV-2 pandemic is an excellent example of what people like me have been warning about for years now.
Yeah. It's many people have been worrying out loud for that, and it just seems that we get at least a C- or a D or maybe an F for some people on how we handled it. So there are more ugly things out there, and so hopefully we can do a better job. Next time something hits. So just kind of give us a context. I mean, obviously, I want people to read the book and stuff, but just a kind of overview of where your roots are, where your eggs hatched, where you're born and raised. And you mentioned some of these three big events. There's one in third grade that changed your academic trajectory. You talk about, eyesight and reading and chess. And so talk about some of these like early formative pieces that kind of set you on the path for much of the things that you do and think about and write about and talk about.
Yeah. So the first half of the book is really called The Unanticipated Path. No one could have predicted from the circumstances of my birth that I would become a prominent scientist in any field. I was born in 1955, the same year that Emmett Till was lynched in Money, Mississippi. The situation for African Americans across the United States was still dire. I talk about how my father had, participated in the Normandy invasion. How he had fought, the battles across France and into Germany, and then comes home to, a violently racist Jim Crow society. My mother, like, African American women of her time period, had to struggle day to day to deal with the ongoing oppression from, working jobs, being the help in rich, white women's houses, to pulling a factory shift at night to make ends meet. My parents were denied the access to a quality education in the Jim Crow South. And so one of the things that they committed themselves to was making sure that their children had an opportunity at education. And so they made the decision to, really buy a substandard house in Westfield, New Jersey, simply so that their children would go to Westfield Public Schools, which was one of the best public schools around at that time period. And so I go into an environment where the people who teach school have little to no expectations for persons of African descent. Also being poor and working class, they have no expectations that people like me are going to amount to anything. And so back then, I talk about the tiered, tracking system that they used in public schools at that time. I'm absolutely sure my parents weren't consulted about which learning group that they put me into. They assumed that I was retarded, so they tried to, put me in a class for learning disabled children. My mother wouldn't have any part of that. And they, of course, considered me a behavior problem because, quite frankly, I was doing my work much faster than they could possibly anticipate. So I was bored. And, what does a 5-year-old little boy do when he's bored in his kindergarten class? He acts out. So, but of course, that story now, which was my lived experience as a child, is now receiving scholarly attention. Back then, it wasn't.
Yeah.
So I talk about an example of a kid who lived pretty much what I was living in the 90s, but didn't succeed. So I had that, moment which wowed a student teacher, because this was not one of the regular teachers who was at the school. She was there doing her student teaching, and she finally decided to ask me about what I was reading. So I'm sitting in the library during our library time, and I'm reading a copy of Harold Lamb's book, The Crusades, which is a college level textbook on medieval history. And, the other teachers had assumed that I was just acting out, reading the big books with no pictures to make it look like I could read. But she asked me, and I told her all about the Crusades and why I thought it was fascinating and who my most favorite characters were and so on. And she was just flabbergasted. I mean, it's hard to pull the picture of her face back from so many years ago, but I do remember her jaw dropping. And the next day, I was switched out of the slow learning group into the fast learning group. That, of course, set me on a different trajectory in life. And I don't know if that would have happened if that one, student teacher hadn't been there and obviously argued persuasively that they had characterized my ability at a young age.
I'm curious kind of internally here. So, I mean, I guess for you as a kid, I mean, what was it? I mean, what was it like for you to just kind of be drawn to those types of books and to read and to try to learn? Was it just this quest for knowledge? What kind of drove you to look at those types of topics?
I was fascinated by adventure stories. So one of the reasons why I read about the Crusades is because, as a young boy, I was enamored by stories of heroism and great knights, rescuing princesses and all that, silly trope. But it got me fascinated so that I wanted to read a great deal about ancient and medieval history. When I was older, my interest really shifted to the comic books of Stan Lee. Marvel, and so I started reading Spider-Man. I started reading, Captain America, the Avengers, and that was the stuff, Fantastic Four, that got me going. And again, it fed my quest for knowledge of science as well, because those comics had, mutants like the X-Men, and what exactly did that mean, and how are these things possible? Space travel. So I was just hungry for trying to address the big questions, how things work, why they were that way. And also, and this is something that really occurs more towards my preteen years and going into being a teenager, the impact of being Black was something that, our parents tried to insulate us from as much as they possibly could, but they really couldn't, because structural racism and white supremacy were just omnipresent in our lives, and so we would always come against that, and you begin to ask questions. Why are they doing this to us? Why do they think that they're better than us? So I'm coming up with King being murdered, and Malcolm X being murdered, and the news, civil rights movement, and just hearing arguments which were so patently false, even for a preteen. I could see that this stuff just wasn't right. So, a lot of my early role models were people like Muhammad Ali and Jim Brown and Bill Russell, who were standing up, in the sports world against racism. And so when Ali said, no Viet Cong never ever called me nigger, that's the kind of stuff that resonated with me because that was the life I was experiencing. So and all of that, the way out of all of that was knowledge, which, as you know, the school systems have been designed historically to deny us.
And I guess in that way, I mean, it sounds like there's almost like your experience is there's a lot of things from the outside world being told of what you should or shouldn't be or what you can and can't do. But it sounds like internally you had this wanting to understand how the world worked, how things worked, how we were able to get to certain places, how we're able to make certain advancements. I guess what was that experience like for this kind of like internal, like just you as a human being or just you as a person, just you as a boy or preteen of wanting to like just kind of explore and understand things in the way the world works, but then having kind of the world around you, whether it's locally or more nationally or et cetera, as being, a black boy or a black adolescent. How did you kind of, as you were growing up, make those kind of, how did you deal with that kind of, I guess you could say, maybe dissonance of sorts?
Yeah, well, I mean, I had the advantage of having a really strong family. And by that, I mean strong extended family. My mother's side, there were 11 siblings. And so by that time, I had a lot of cousins on my mother's side. My father's side, their family was 8. A lot of cousins on my father's side. Many of them were older, obviously, than us. And so we got to see people who were achieving and standing up to the way society worked. Probably one of the most important people in giving me a sense that I could do whatever I wanted to do with my Uncle George, who was an executive in the Vornado Corporation, which had a number of retail stores in the New York, New Jersey area, and he was very prominent in that corporation. And seeing him go to work and and watch people jump when he said, you do this, and and seeing an African American man have that kind of respect, and people actually listening to what he said, was transformative. So it was really, I think, a sense from my family, my own parents and their personal day-to-day heroism, and my extended family, that no matter what they say to us, we can do whatever we set our minds to do. So I was really raised, in the African American version of that Puritan ethic, which is you work hard and eventually, your talents will rise to the fore. And that was a belief that was instilled in us from a very early age.
Yeah, I think that's definitely instrumental. That's super important. You land at Oberlin College and you start to find your way, your field of study. Just kind of say, what that experience was like and how you started to get into the biological sciences.
I went to Oberlin, again, pretty much convinced I would be either a biology or an astrophysics major. In high school, I had done really well in biology. I had 2 outstanding biology teachers at Biology 1 and Biology 2. But again, having grown up in the era of Star Trek, the idea of going into space and exploring it was still, part of my, psyche. But I had really bad experiences with physics and mathematics when I got to Oberlin. First, I had no understanding of what Oberlin was. And, I was the first person in my immediate family to go to college, and I only had one cousin that had gone to a historically black institution. So there weren't a whole lot of us who had gotten into college yet. So I really had no idea what that little college that no one had ever heard of
Mm-hmm.
The only reason I went there was because their recruitment brochure showed kids on it that looked like me.
Wow.
Because I got all sorts of recruitment materials from Ivies, and it's just nothing but a bunch of white kids.
Mm-hmm.
And that, I went up to visit MIT on a recruitment visit. The campus atmosphere really didn't appeal to me. So when I ended up getting accepted to Oberlin, I went out there and I was just hit with tremendous culture shock because everybody there was in the top 1% of their class. So when I was at Westfield High, I was clearly one of the smart kids there. I dropped into Oberlin. I'm one smart kid, a whole bunch of smart kids, and who have, going with them, upper middle class culture, which I didn't have. So the hardest thing for me was to deal with this culture shock of being a poor black working class kid coming to this elite liberal arts institution where everybody there, vast majority of people there, had generations of college in their family. There were the daughters of Hollywood stars, like James Coburn's daughter was there. I mean, I was like, I was like, yeah, I'm definitely not in Kansas anymore.
Right.
And, initially I was doing really well. I was outstanding. Like the first chemistry test that we took as freshmen, we were on what was called the Keller plan, where you could take tests when you were ready to take them. You could take as many tests as you wanted until you got through the semester. So the first test that the professors gave in Chemistry 101, only 3 people passed.
Wow.
And that was me, my roommate, Mark Phillips, and his cousin. And none of us studied together. So it just gives you a sense of how challenging these exams were. And so first semester, I was pretty much on top of things. There were 4 units. I took a total of 5 tests. Go to the second semester, which takes on, some different topics. And I was lost. Coming into the last week of classes, I had 3 units to go. I had taken like 25 tests. And in a week, I had to pass all 3 to be able to get out of class. But the good news was, because I had taken those 20-some tests, I pretty much knew everything in chemistry that anybody could ever want to know by taking it. So in the week of needing to take 3 units to pass, I am done. But things got harder from there, and also dealing with personal drama at home, mom being sick, dealing with trouble getting the finances to stay in school. So I'd go home in the summertime, and while my college friends and classmates were off doing really exciting things like going to museums, going to Europe, and stuff like that, I'm in a lumberyard. Working 9 to 5 every day to make the money for tuition next semester, and then dealing with relatives being sick, mom being sick, getting sick myself. Sophomore year, I went on academic probation. And this was, again, one of those points where, if I hadn't responded in the right way, we wouldn't be having this conversation. And that's one of the things that sort of comes through in the book, is that there are so many points.
Yeah, there's like these crossroads.
The journey, where if I had made the wrong choice or had not been capable of stepping up, we wouldn't be having this conversation.
Yeah. That's interesting, because I think that's, the kind of universal principle here is that, obviously there are many things distinct for you, but I think that's true for a lot of people. And it does seem that there's a lot of really strong emphasis on your very strong family unit and how supportive they were for you to really have some really guiding principles, guiding values that were there. Obviously, as like any of us, right? When we get out of the house and we want to be on our own, and we're going to be dumb and make silly mistakes. But I think if you have a solid core, I think that can help kind of navigate some of those areas. you end up getting to University of Michigan, doing some work there. You don't finish there. You did talk about in the book some of the politics you became involved in during that period. And then you get to Wayne State University and finish in evolutionary biology. So maybe just briefly, share with us that kind of trajectory and what happened.
Yeah, so I went to Michigan. And again, I tell a story in the book, and it's one of these amazing stories. So I went first to the Institute for Tropical Disease at the University of Lowell, which is now UMass Lowell, for my master's degree work. And things, went 180 degrees from my undergraduate, because all the things that were weaknesses for me as an undergrad became strengths in graduate school. Another big thing was that I wasn't doing sports anymore, competitive sports like I was as an undergrad. So I had more time to put into my studies. And probably the most important thing was that now as a teaching assistant, I really had to know the material better so that I could teach it to the students that I was charged with teaching as a teaching assistant. So all those things made me a much better student academically. And certainly my greatest skill was, solving scientific problems, which doesn't really come through with undergraduate training, which is more of you tell us, we tell you, you tell us back.
Right.
That's not your ability to do science really isn't brought out in that environment. So in graduate school, I'm definitely, deeply engaged in research. I win a National Science Foundation graduate research fellowship, which is the most prestigious graduate research fellowship they gave at the time. And I applied basically to two programs, Harvard University and the University of Michigan. Now, the reason I decided to apply to Harvard is I met Stephen Jay Gould when I was at the Marine Biological Laboratory in the summertime. And he'd mentioned that, there might be somebody at Harvard who'd be interested in working with me. And that person was Richard Lewontin, who was one of the greatest population geneticists of the 20th century.
Absolutely.
And so I applied to Harvard. I learned after the fact what happened with my application. But I get this strange letter back from Harvard, and it says, Dear Mr. Graves, your credentials are entirely in line with you attending Harvard University, but we cannot find anyone who's willing to take you on as a graduate student. Therefore, we are declining your admission.
And that's a very strange letter.
I had actually talked to Lewontin, and he, we'd had conversations back and forth during my application process. And he told me that he was willing to take me as his graduate student. I later found out that he wasn't at the meeting when they were making decisions on admission of graduate students for whatever reason. And so no one else there knew. But the real question is, of course, why wouldn't you take a student who has won a National Science Foundation graduate fellowship?
Right.
Because that student is essentially free to the program.
Right.
Because the National Science Foundation pays for everything, pays for their tuition, pays for their stipend.
There's no cost for them.
There's no cost to the program to admit me. On top of that, clearly, from my application, unless you're thoroughly blind, you have to understand that this is the first Black student who's applied to your program in ages, right? So why wouldn't you want to take an African-American student interested in evolutionary biology with a National Science Foundation program?
Right.
Okay. So that's a mystery that I've never been able to answer. And it sort of speaks to the environment within evolutionary science at the time. So I ended up going to Michigan, which I think for me really was the best choice anyway. And they were really excited to have me in their program because it's a complete opposite response. And again, when I get there, people are playing the affirmative action mantra. You're only here because they're trying to get more Black students into the program. Blah 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 blah. But one of the faculty pulled me aside and said, you shouldn't listen to that because of the students we admitted this year, you had the highest score on the graduate record exam in the area of quantitative reasoning.
It's impressive.
Yeah. So the reality of who I was versus the anti-affirmative action racist rhetoric that was, put in the face of virtually all Black students in the graduate program on the campus at the time, again, complete disconnect between who you were and what people thought you were. Mm-hmm. And that was also at the time when I came into contact with folks like John Vandermeer, who helped me to understand that it really wasn't me. It was a system that was at fault. Mm-hmm. Because up until this point in my life, I had, chalked up all of my shortcomings to, problems that were associated with me and believing that I wasn't good enough. And this is when I really am beginning to feel the imposter syndrome. I'm not supposed to be here. People reinforcing the idea that you're not supposed to be there. And this is when I began to get the analysis that allowed me to work through that the imposter thing was, in fact, a prop that helped to maintain, white supremacy. So this is a very important time in my career.
Yeah, absolutely. I think it was when you were finishing up at Wayne State, and so you get your PhD in evolutionary biology. There's a few things here. So, am I wrong on this? You're the first African American to have a PhD in evolutionary biology. Is that correct?
Yeah. Now, and again, that does need some qualification because there were some African American scientists before me who had some interests in evolution. In fact, one guy in the 1960s actually did a thesis that anyone would call an evolutionary biology thesis, but he was really more of a fish biologist and in a zoology department than somebody who really studied evolution to understand how evolution works. So that's why I claim being the first African American to be an evolutionary biologist. Certainly on my PhD, it says evolutionary biology.
Yeah. You get the moniker, I think it's here, right, about Black Darwin. And I was wondering how you felt about that, right? How you still feel about it.
Yeah, given that it came from the students and it was a sign of affection, particularly from the African American students when I was an assistant professor at UC Irvine, I certainly, was willing to ride with that moniker, because it came from a place of love. So I absolutely have no problem with that.
So this is coming from your work on Drosophila, is this correct? And
Drosophila is a fruit fly that was a workhorse of early genetic science. In fact, you don't know this yet because the book hasn't come out, but the Routledge Encyclopedia of Science is coming out in a few days.
Oh, nice.
It's Encyclopedia of the History of Science is coming out in a few days. And I got asked to write the article on the history of American genetics.
Oh, wow.
And that's a really big deal because there are a lot of American geneticists.
Yes, there are.
They could have chosen anybody to write that piece, but they asked me to write it. I felt quite honored.
Genetics in the United States has quite the history.
But again, a lot of the major developments in the modern genetic synthesis with evolution occurred from thinkers who were in the United States. And if you look at my academic genealogy, I am a direct descendant of these people. Of course, at the time when I was working on my PhD, I had no idea my connection to the history of the ideas that I was working on. I was first African American to earn a PhD in evolutionary biology. My model system was the fruit fly Drosophila melanogaster. I was working on life history evolution, which is the relationship between traits associated with the survival of an organism and its reproduction.
So, just talk about the evolution of aging with your work. So what was it about your work that was like really made it stand out, and just maybe get into some of the nuts and bolts of it a little bit? So you don't have to spend a lot of time on it, but I just want to, I know that's like the thing, and that was the big thing.
This is one of those big moments in science.
Yeah, yeah.
I mean, it really was. It was a scientific revolution that occurs in the thinking about aging that I was a direct participant in.
Mm-hmm,
Now, of
mm-hmm.
course, at the time, you don't really realize that you're in a participant in the midst of an idea that's going to overturn everything
Mm-hmm.
that was thought before you.
You're just doing science.
You're just doing this work.
Yeah.
But, prior to the work that I was engaged in the mid 1980s, people did not understand why organisms aged. And this is a conversation that goes back to Darwin, to Alfred Russel Wallace,
Mm-hmm.
to Hugo de Vries, one of the first geneticists who understands the separation between cells that just carry out the physiological function of the organism, known as the somatic cells, and the cells that are responsible for producing the gametes that form the next generation, the germline cells.
Mm-hmm.
So people are beginning to ask these questions. In 1952, Peter Memoir, then one of the great theorists of the neo-Darwinian synthesis, writes a book entitled An Unsolved Problem in Biology. So here we are in 1952, and people still don't understand why organisms age. And the ideas that people have, by the way, are still somewhat prominent today. And that is, looking at it from the point of view of more proximate mechanisms, like accumulating molecular damage, or accumulating, mutations in the genetic code in somatic cells over time, or the cumulative effect of oxidative stress from respiration in cells. All those things are mechanistic ideas, but they still don't answer the big why questions. Why do organisms age? And so it turns out that it has to do with the separation between the somatic tissue and the germ tissue. Because if you actually think about it, we are all descended from the germ tissue of the last universal common ancestor. And it was the first living thing on Earth. We literally all carry genes that were in that organism, or not, or we wouldn't be here.
Right.
But of course, we're in a very different somatic form than that last universal common ancestor, which was probably a bacterium that lived on an oceanic vent at the bottom of the ocean. Right? We're clearly not that thing.
No.
But we have genes that were in that thing. So recognizing that it's the separation between somatic tissue and germ tissue, that natural selection becomes unconcerned with bad things that might happen in the somatic tissue after the reproduction of the organism has finished. So this is ideas that were developed by people like Sir Ronald A. Fisher in the 30s, where Fisher, derives this idea of the reproductive value, and then realizes that theoretically, anything that happens after net future expected reproduction is gone to zero won't be acted on by natural selection, because it can't interfere. You've already finished your reproduction. So what Michael Rose did is he realized that Fisher's idea could be tested experimentally. And he chose fruit flies because, one, we knew a great deal about fruit fly genetics from the early history of genetics work. The organisms were small, so you could grow a lot of them for very little money in small space. And their generation times were short. So you could get many generations with these organisms in a relatively short period of time. So Michael's, critical experiment was saying, well, if Fisher's right, if we can change the timing of reproduction, then we should also change the pattern of aging. And so he set up a system in which the control flies were allowed to grow as larvae and start laying eggs for 7 days. And then he stops the system right there. Okay? That population is literally killed. placed in the freezer, but their eggs are allowed to develop at 7 days. He takes a second population where instead of killing the adults at 7 days, he collects the eggs at 14 days. And note, none of the eggs that were laid on day 13, 12, 11, 10, none of those make it into the next generation. So he's only collecting the eggs that are picked up, that are laid on day 14. Control group was laid on day 7. A few generations later, he pushes it to the right again. This time you're collecting the eggs on day 21 and not day 14. And then day 28. And so finally, he arrives at a population that eggs are collected on day 70. That is 10 weeks. And these flies are still vibrant now, as 12 generations have gone by. They're still vibrant, they're still active, and they're laying plenty of eggs on day 70. The control group, whose eggs were collected on day 7, if you try to let those flies live out to day 70, there's no way they're laying eggs. They'll all be dead by day 7. And so what Rose's experiment proved was that Fisher's idea and then Memoir's idea was correct, that there was a declining force of natural selection acting on the age of adult somatic tissue. So if you pushed reproduction to the right, in terms of when it happened, the flies would evolve the physiological capacity to live to their timing of reproduction. And so this is where I come into the story. So Michael has published this experiment in Evolution, which is the premier journal of our discipline. My PhD advisor, Leah Luckwoodsville, did a similar experiment around the same time, and they published in the same issue of the journal. The papers are literally back to back. Both of them show that you can change the pattern of aging by changing the timing of reproduction. So now the question is, what else has changed in the fly? So Michael's group goes to work on looking at some physiological traits, such as desiccation resistance, starvation resistance, ethanol tolerance. Phil Service tries to get the flies to measure their flight capacity, but he fails for reasons he doesn't understand. I start my work and I ask myself, if I were going to look for a physiological difference between these flies that live a long time and these flies that live a short time, where should you look for that difference? My reasoning was look at their flight, because these things are flies. That's what they do. And so I figured out how to get them to fly by simply knocking them out with ether, tethering them to a small fishing line, very light test fishing line, so their wings were free to move, and suspending them. They have a physiological, behavioral unit. The word I'm looking for is behavior, okay, that once their legs are lifted off the ground, they will fly. They don't have a choice about it. So there's a neural circuit that makes them fly. So I could fly these flies to exhaustion. And sure enough, I found that the flies that had been reproduced late and lived a long time were flying for 3-4 hours. Whereas the ones that were reproduced early and lived a short time could only fly for about 30 minutes.
Wow.
So there is a huge differential in physiological capacity. And as such, my work showed that not only would this work postpone aging, but it would also increase the health span of the organisms. So the reason these flies can do all these things that they do, physiological resistance, greater flight capacity, is they're physiologically healthier. And they're healthier for a longer portion of their lifespan compared to the ones that were reproducing early and who had, very much lower physiological capacity compared to the long life flies. And that's what sort of put me on the map as a scientist.
Well, it's obviously tremendous. How did this get I guess, export it to other organisms, and then maybe all the way up, maybe to humans.
Here's the good news. Okay, memoir theory doesn't really work on the basis of any particular set of organismal characteristics. The only thing that the organism has to have is a separation between its germline and its somatic line. And that is all animals. So the reason that also, Michael and Leo use fruit flies is because they adhered to the principle necessary to test the evolution of aging. Okay. Now, the particular physiology of aging is going to differ depending upon the group of animals in question. But the main theme, which is this first separation between germline and somatic line, and also how energy is apportioned between survival and reproduction, that holds for all animals. So, in fact, I have a piece coming out in the they're not a podcast, but they're a what do we call these things? Blog. Yeah. I have a piece in the blog Culture Rico coming out in a few weeks where I discuss what those early experiments meant for understanding aging research now in 2020.
Yeah, that's fantastic. Yeah, I mean, well, look, I can I can definitely get why people would get very excited about this in biology. I mean, it's groundbreaking in a lot of ways, and that has to just kind of put you on the map. And then it seems like maybe at that point, I mean, other people did as well, but maybe more kind of initially. I think you talk about it towards the end of the first part of the book, where then people were kind of coming to you definitely on your merits, like what you did was fantastic and people wanted to talk to you about it and then like work with you and collaborate and all these things. I guess what was just briefly that experience like of having like, you just kind of weren't trying to do this. You just were doing the science. You had some really good hypotheses. You tested them. They worked. You found some really awesome things. And then how your career kind of went after that. What did that all kind of like, what was that experience like, I guess?
Yeah, well, I mean, at first, it was incredible because, I had been dealing with imposter syndrome for all of my previous existence in scientific research. And then to get a major result like that,
absolutely,
everybody was acclaiming as being of great importance. And to tell you a funny story, so the first time I go to the evolution meetings, I go to breakfast and, I'm up early because I was always an early riser. And so I'm sitting at a table all by myself. And then this old guy with white hair walks into the dining hall. And I look up and I say, that's John Maynard Smith. And for the listeners who don't know who John Maynard Smith was, he was the equivalent of Albert Einstein in evolutionary biology.
Yeah.
So, John Maynard Smith walks into the cafeteria, and first I'm just completely enthralled that I'm even in the same room with this guy.
You're fanboying, complete fanboying.
Completely, just, wow. That's John Maynard Smith.
Right.
Across, over there in the buffet line. And then he, picks up his breakfast and he starts walking over in my direction. I'm like, I'm looking for who's over here, right? There's nobody over here. And all of a sudden he sits down at my table and he looks at me and he goes, "You're Joe Graves, aren't you?" I was like, yeah. I was like, and he says, I read some of your papers.
Wow.
And they're really good. And at that point, I was just lost for words. I was just, completely.
I can die happy now. I'm fine.
Yeah, really, completely, foolish looking. And then he, gets off and walks away. But then a few minutes later, another icon of evolutionary biology in that period walks in, and it's George C. Williams. Williams was one of the guys who first, put this idea of, the trade-offs between short and long life on the table with his antagonistic pleiotropy genetic mechanism and all sorts of other major works in evolution. And he goes through the line. He walks over and he sits down next to me.
Oh, wow.
And he says essentially the same thing. And I'm like, oh my gosh, I mean, why are these guys come? Because, what we had done, and particularly my work at that time in that area, was that important.
Yeah.
And people who knew recognized it. So yeah, it was a total blast. We had mention in Discover magazine. We had a cover of Life magazine at that time. It was a total blast.
Yeah, it's just so fantastic. Yeah, it's so cool to hear those stories. So I want to obviously be mindful of your time. In the second part of the book, you talk about many different topics. I definitely want to get your opinion. You talk about sex and gender. You talk about gene editing. You talk about creationism, which is really interesting as well. But I do want to talk to you about race and IQ. You can just give the abbreviated version of it. So I've talked to different people here on the podcast about this, and I know you've written a lot about it and you've researched a lot about it, and obviously your work with genetics makes it super important. So, I want to understand kind of your take, and I have a little bit more specific questions, so we can do the brief summary of it. But I guess the one thing here that I want to know is many people, I think, will emphasize one aspect of this or the other, right? So we know that IQ is heritable, like all traits of humans are heritable, but some people will overemphasize or make sure to emphasize how that is heritable. And they'll say, yeah, it's environment too, and socialization, but yeah, of course, but they never talk about it. And then the reverse, right? You have other people on the other side that will, say, well, it's all environmental, it's all socialized, it's a little bit of genetics, but whatever. So how do you kind of approach this? And then just in terms about IQ and intelligence and the heritability, and then there's the race component as well between groups and within groups. So how do you what's your kind of angle at looking at this?
Yeah. So first we'll start with IQ.
Yeah.
In genetics, the ability to use, quantitative genetic tools to study the genetic contribution to a given phenotype. And the phenotype is, what the organism manifests.
Yeah.
And in this case, that phenotype is IQ.
Right.
It's very much dependent upon the definition of the phenotype. So if I were going to say to you, let's use quantitative genetic tools to study the distribution of height in human beings, I can do that very well because I'm in a much better position in defining this phenotype that we call height, so that I can now more reliably measure genetic contributions to that phenotype. When you start out with a phenotype whose definition is not agreed upon by professionals in the field, you really start out with a huge problem. What exactly does IQ mean? There are at least 3 or 4 different definitions of IQ that have their own adherents within the psychometric community. Yeah. So you start out already talking about a phenotype who you really can't come to an agreement with. Then the second thing is, what is the meaning of this phenotype? Even if we could imagine that we could define it, what is its meaning with regard to how it operates in human society?
Right.
Now, you may remember my writings on this in the 1990s about the bell curve and the fallacies that Bernstein and Murray presented regarding the significance of IQ in Western society. I mean, their analysis was just pure garbage. And so they overinflate the significance of these test scores for what they actually mean for individuals living in this complex modern society. So that's another problem. And then, we get to the question of, well, let's say even this thing is true and it has some meaning in society. What is its contribution to evolutionary fitness? Because that's where the psychometricians really fall on their face, because they measure this phenotype and they claim that there's an innate genetic contribution to it. But then they can't really explain why this innate genetic capacity should differ amongst human populations. They do a really bad job of that. In fact, one of the people who tried to put psychometrician thinking on an evolutionary basis was J. Philippe Rushton. Rushton used a life history theory analysis. And in fact, his was the most credible idea because all the other previous ideas were just straight nonsense.
Mm.
But what I showed in the early 2000s and the 2010s was that Rushton's life history analysis was completely bogus.
Mm.
It was backwards. If we took a life history approach as defined by Rushton, you would have had Africans having the highest intelligence, and you would have had your Asians having the lower intelligence. If you had applied the life history theory, which he cribbed from Pianka and Wilson, if you'd applied it correctly, you'd have gotten the exact opposite results than he defended in his book. So, coming to the modern day, we still have this question, and this one, probably again, I'm talking about, this guy's name he's the one who wrote Who We Are and How We Got Here. I can't think of his name.
David Reich?
Yeah, David Reich. So
right.
Reich comes up with a, statement that, of course, human populations differ in genes associated with intelligence because they differ in genes associated with all sorts of other traits. But of course, that logic doesn't follow because the genetic architecture of all traits are not the same. Some traits, it's relatively easy to understand their adaptive nature and therefore their genomic composition. And we've done that for a number of traits in humans around the world. And others, the genomic foundation is so complex that there's no way it would hold up over generations of selection, even in the same environment. And so actually, when I gave the 2016 lecture for the 150th anniversary of the Peabody Museum of Archaeology and Ethnography at Harvard, that's what I said in my talk. Now, Reich was in the audience, and he obviously was taking notes because in his book, in his chapter on that, he cites me and says that my analysis is wrong. That, of course, natural selection could lead to the differences in intelligence that we see in human populations. And essentially, he was saying that this Graves guy doesn't know quantitative genetics. It doesn't know how natural selection works, even though I spent my entire career using experimental evolution on complex traits, showing how they work. And that was the rationale behind my claim that while there is certainly a genomic contribution to cognitive function, that the notion that there has been uniform selection differentiating human groups in this trait is absolute nonsense. Okay,
yeah, so that's what I was going to ask. The main sticking point here is not that there is genetic contribution to cognitive abilities in humans or IQ, if you want. Your sticking point here, or where you disagree or where you diverge, is how it is laid out over sequences of generations throughout time.
And how could you use that to explain the differences between supposed racial groups?
Yeah.
So if for example, you measure using IQ tests, performance IQ tests in the United States, there's a historical difference between African Americans and European Americans in their performance. Yeah. I don't dispute that.
Right.
The data is clear. There is this difference. What I dispute is the causality behind the difference.
Sure.
In other words, if one group lives in the better environment and is socially dominant, and has access to all of the tools which helps a person improve their cognitive function, and another group lives in an environment where all of the things that you need, like a good nutrition, good housing, a lack of exposure to toxic metals, and so on, is very high. Then if you look at their performance, of course, the one that has social hegemony is going to perform better in cognitive tests than the one that is socially subordinated. And not only that, we've seen this all over the world. So it's not just African Americans and European Americans. It's virtually every society in which we look at socially dominant groups versus socially subordinated groups. the socially subordinated groups show a variety of physiological pathologies, including those associated with cognitive function. And so therefore, people like me were rare because I grew up in an environment that was not conducive to me becoming an intellectual. Whereas someone like David Reich is far more abundant because he grew up in an environment which was far more conducive to he and people like him becoming intellectuals.
So you're saying that in many ways, because I can hear the counters to this already, but that you're saying that, like, you yourself are an example, right? That you don't fit in, what many folks in an environment where they didn't have access to many, many different types of things, socially, by class, by race, all the rest. But you were able to, transcend.
Yeah,
but you're saying, like,
again,
that happens, but that's not the average.
Yeah, and again, important is the statistical character.
Yes. Yeah.
So because of growing up in a deficient environment, people like me will always be rare. Growing in an abundant environment like David Reich, people like him will always be more common.
That's a nice way of putting it. Yeah.
And that's not saying that this has to do with their genomic composition.
Yeah.
Because again, when we look at, genome-wide association studies that measure contributors to this cognitive function using this narrow definition of intelligence that psychometricians use, their GWAS is performed so poorly that they don't even talk about it. That's why people like Paige Harden make their arguments on educational attainment.
Yeah.
Because when you look at the percentage of IQ explained by GWAS, 1.2 million people, the Lee study that she cites in her book, it's only 7%. Goes up to 11% when you use educational attainment. So that's why they use educational attainment, because that is better explained by GWAS. But then when you look at the number of, markers involved, and again, in the Lee study, you're talking about 128 markers explaining 11% of the variance, which means each one of them is less than 1%, much, much less than 1%. So even having that knowledge that there are, portions of the human genome that do contribute to differential cognitive function, how would you ever intervene to use that genetic information to make people smarter? My argument is that this whole thing is a fool's errand, but it's a fool's errand associated with a particular ideological climate. In other words, it's so much easier to blame people who are the victims of discrimination and injustice for their situation and say, oh, it's their genes. And we can't do anything about that because it's their genes. If it's not their genes, then we can do so much easier to do things about it. And, Harden talks about that in her book, although very clumsily and not well reasoned. And you can read my review of her book in The Lancet.
Yeah, and I have some. I think some people. I'm not saying she does, but I know some people really put a lot of their weight behind GWAS studies, and I'm not quite there with it. I think that there's issues with GWAS studies. I think some of them are fine.
Issues, yes,
yeah, there's some of it's fine. I don't think we shouldn't do them at all. But I think that more caution to before putting the weight behind it. So, but there's some interesting ideas there for sure. So the last question here. I really did like the race and IQ topic and hearing your perspective. It's one that I think is important to hear in all these different perspectives. So I'm glad that you're able to share that. The last question I have is obviously you've been groundbreaking for the science, but also for representation. And I guess we could probably riff on this for a long time, but I just briefly, how do you make sure, or how do you want to be perceived where you can kind of have both, where one isn't, like you were saying earlier, it's just the token or the affirmative action, or like, but like where people see you for the science, but then also that, yes, like for young, Black men and women, but for, Black men and just other people of color, like, hey, look, this guy can do it. He's got the chops, he had to work really, really hard. it's good to see people like that to say, hey, there's not just, one group of folks or whatever. How do you kind of, I guess, now at this point, in your career and things like that, kind of balance both, where it's like on the science, but then also on some of the representation as well?
Well, one of the ways that really helped me bring that into balance was becoming a professor at a historically Black university.
Oh, that's nice.
Now, the assumption, of course, at many historically white institutions is that historically Black institutions are intellectually inferior. There are a lot of resources we don't have. And I'm sure you've read, recent historical analyses that show why we don't have those resources. The fact that the former Confederate states who agreed to Plessy versus Ferguson in 1879, separate but equal, never invested in Black and white education in those states equally. And they also secretly diverted funds from Black education to support white education. And so that explains why a school like mine, which is the largest public historically Black university in America, we don't have the infrastructure of our neighboring schools like North Carolina State and UNC Chapel Hill. And, earlier this week, or actually last week, I was at a conference with science teachers in Charlotte, and I told them that if they gave me the infrastructure that NC State and UNC has, I would transform the demography of science, in a few years. I mean, I literally could do it. I and my colleagues, we could do that if we had that infrastructure, but we don't. And so what I have been trying to do since I've been here, I've been trying to build that scientific infrastructure. And so we brought in a number of large, grants from the National Science Foundation. These are not educational grants. They're peer-reviewed scientific research, basic scientific research grants. Okay? And that's how we get the reputation of being, a research intensive. And we're moving now to try to become America's first Research One historically Black institution.
Very nice.
That's how we get the moniker off of just being, sort of tokens by doing outstanding science and having the reputation for doing outstanding science. And that's also what will then attract some of the best Black and brown minds onto our campus, where they will get superior training and mentorship that they're not getting at historically white institutions. And that's one of the things that comes out of my story, that I am a survivor of the historically white institutions. Okay? I didn't really thrive there. I survived them. Whereas what I am attempting to do here at the end of my career is to create a scientific training environment where Black and brown intellectuals can thrive and not just survive.
Yeah, no, that's wonderful. It's also wonderful because it sounds like you're really trying to make some of the systemic change there. Now that you have this very long career, you have all the acclaim and trying to do it kind of, after, when your career is done and for all these other generations, for people to be there. So that's really wonderful to hear. Well, the book is called A Voice in the Wilderness. A pioneering biologist explains how evolution can help solve our biggest problems. It's out everywhere through Basic. Where can people find you? Online or anywhere else, website or your papers?
If you Google my name, Joseph Graves Jr., I'm the first person that comes up on Google, at least. Yeah. Until there's another Joseph L. Graves Jr. who does better science than me.
That's great. Well, Joseph, this was such a delight. It really was a pleasure and an honor to talk with you about your work and your life and some of the issues. I really quite enjoyed it.
Thank you, sir.
Yeah, thank you.
I very much appreciate you having interviewed.
Of course.